building sector, building materials, all those follow those major industries. So when we talk about the capturing of carbon dioxide, we have to look at what are the major sources of emissions in India and how we can control. So if you talk about the fuel composition, which fuel contributes how much CO2 emission in India, then we see that coal is having the largest emission in India, which is at 72.2%, followed by the oil and the natural gas. Now moving toward the technology, what is carbon capture and why we are talking right now at this moment. In fact, when we talk about the carbon capture, we are talking about the capturing of carbon dioxide from the point source or from the atmosphere. So my particular presentation is focused on the point sources. When I talk about the point sources, it is about the industries which are emitting the carbon dioxide into the atmosphere. Industries like power industry, steel industry, oil refineries, all those, because they are the major contributor of carbon dioxide emission. The another way of capturing carbon dioxide is from the direct air. We call it direct air capture. In fact, we know that from the pre-industrial levels to present day, we have contributed CO2 into the atmosphere from 200 ppm to something around more than 400 ppm. So carbon dioxide levels are rising. And in fact, this direct air capture is talking about the capturing the carbon dioxide from the air itself. But the major challenges of direct air capture is the cost. And in fact, it plays a major role when you are talking about the deployment. But when we are talking about the point source capture of carbon dioxide, then we see that industries which are emitting the most of the carbon dioxide in our country, in fact in the global level itself, then we have to find out the ways how this carbon dioxide can be captured. And the major challenge of carbon dioxide capture is not the carbon dioxide capture itself, it is the utilization of carbon dioxide. Because we see that if you are able to capture the carbon dioxide, but what we will do with that carbon dioxide, it is again poses a big challenge how we are going to deal with the captured carbon dioxide. There are so many ways right now people are working on, but still we need a cost-effective and viable solution. Don't say that only a single solution is feasible. There may be multiple solutions, but we have to work out and we have to find the possible ways. Still, industries and in fact the academia are working hard to find a viable and cost-effective solutions where we can utilize our carbon dioxide. So let me talk about how the carbon dioxide can be captured from the point sources, which is from the industry. So there is one is the oxy-fuel combustion. This is the
Sir, your mic is muted.
okay.
Sir, sorry, turned off again.
Okay. My slides are visible now?
Yes, sir.
Okay. Can anybody please just tell me where I was last time you have listened me?
Yes, sir. A few slides, sir.
Have you guys please listen? Tell me that where I was last time, like when you have able to listen me.
Sir, just 1 minute ago. So point carbon capture you were about to explain.
Okay. So I was talking about the point sources of carbon dioxide emission and what are the two ways where we can capture the carbon dioxide. The one way is to from the point sources like industries, power, steel, cement, oil refineries, and another way is from the air. So I was also telling about the biggest problem of this sector is not about the capturing carbon dioxide, is the utilization of carbon dioxide. How we are going to utilize the carbon dioxide. because a huge amount of carbon dioxide, if we are able to capture, then it will again pose a big challenge where we are going to use this carbon dioxide. So there are ways people are working on, like enhanced soil recovery, the conversion of carbon dioxide into some fuels, some chemicals, or in fact some using it into building materials and so on. So let me talk about the carbon capture ways. This is particular about the point sources, the industries, in industries how we can capture the carbon dioxide. So there are basically three main ways. The first one is the oxy-fuel combustion, in which we are going to burn the fuel, the fossil fuel in the presence of pure oxygen, which help you to reduce the bulk of flue gases generated, and we will get the concentrated CO2 into the flue gas, which will reduce the cost of capture. But the major problem with this particular way is the requirement of pure oxygen. For pure oxygen, you will require air separation unit that will add up the cost, and further you need to set up a new plants for this kind of way. The another way is pre-combustion. When we talk about the pre-combustion, we are talking about the capturing of CO2 from the syngas. Basically, it is being used for the integrated gasification combined cycle plants. In fact, in BHL, we are working on the coal gasification, where we are going to gasify the coal by our own indigenously developed technology, and from this coal we will get the syngas. This syngas will majorly comprises of hydrogen, carbon monoxide, carbon dioxide, moisture, and other gases. The advantage of capturing the carbon dioxide from this way is that we will get a high concentration of carbon dioxide, and it can be captured from the physical or chemical ways. So at present, in fact, BHL is working with Coal India Limited, and we are planning to set up a big plant on coal gasification in India, which will capture the carbon dioxide also, and it will produce the ammonium nitrate from the coal. The another way is the post combustion. This is the most, you can say, the feasible solution we are looking for, the post combustion. Why we are talking about the post combustion capture of carbon dioxide? It is why, because in India we are having industries which are quite new in setups. In fact, their assets are quite new. It is nearly 10 to 15 years old. So it is not feasible that you will directly go into the oxy fuel and pre-combustion, because it requires a new plant to be set up. In the post-combustion method, you don't need to disturb your existing setup. You just need to install another carbon capture plant, which will take the tap from your chimney, and it will capture the carbon dioxide from your flue gases. So this post-combustion carbon capture, at present, industries are looking as a possible way of reduction in their carbon dioxides. Now, let me talk about the post-combustion technology. What are the technology solutions available in the market? So the first one is the solvent-based technology. The solvent-based technology is the technology in which some physical or chemical absorption is taking place. We need some solvents, like when we talk about the physical solvent, like solvent like methanol or some specialized solvents can be used. When we talk about the chemical absorption method, then the special amine solvents are being particularly used in the industry, which are, you can say, effectively able to capture the carbon dioxide from the flue gases. The another option, which is also, you can say, an emerging one, is the solid adsorbents. Solid adsorbents are particularly deployed through the method called PSA or TSA, the pressure swing adsorption or temperature swing adsorption, in which we require a solid adsorbent which capture the carbon dioxide from the flue gases. However, at present, I am working with the industries. We found that it is not deployed on very large scales. When we talk about the capturing of carbon dioxide from the industry, we have to see that how the huge amount of carbon dioxide can be captured using this particular solution. The other solution is the membrane separation, where some membranes is being used to capture the carbon dioxide from the gases. And there is also a very common method, in fact it was also one of the oldest methods, which was the cryogenic separations. The cryogenic separation is nothing, it was just cooling down the gases, and you just separate out the gases based on their liquefaction temperature. So now we have to see which of these solutions are feasible to deploy in the industries. Right now, people are working on various solutions, and industries people are also just starting to find out which solution is better suited for their applications. So, in fact, I have been working in these areas, and at present we found that the solvent-based absorptions, in fact, the chemical absorption, are more suitable for the flue gases. Remember, I am talking about the flue gases itself. So when we are talking about the flue gases, it had certain other constituents apart from the carbon dioxide, which hinders the physical absorption, and you can say which reduces the cost of capture, like the SOx, presence of SOx, NOx, oxygen, or some other impurities like particulate matters. So people are all right now looking the amine-based solution, because they have a big, large commercial plant references across the world, which are running successfully to capture the carbon dioxide from the flue gases. So let me talk about the post-combustion carbon capture from the amine solvent-based technology. In fact, I am talking about particularly this technology because at present, I am not talking about the future, because people are working on the other solutions also. But at present, when we talk about the capturing of carbon dioxide from the flue gases, then this technology is having the highest TRL level, which is the technology readiness level, and it having a huge amount of, you can say, commercial references, which are being captured from the variety of industries like power, cement, steel, and so on. So in this technology, there are chemical solvents is being used which are amine based. It may be MEA, MDA, or maybe combination of several amine based solvents and having some buffer salt embedded into it to reduce the impact of impurities in the flue gases. In this technology, you see there is a pre-scrubber. This pre-scrubber is nothing, it's just a column in which we wash the flue gases from the caustic or maybe some alkaline solvents, which removes the SOx, NOx, or other gases. I'm particularly talking about the capture of this model, which I am showing you. It is the capturing of carbon dioxide from the flue gas of power plants, because power plant is having SOx and NOx. That's why this pre-scrubber is deployed here. In fact, in some industries, it may or may not be required. It depends on the type of composition of your flue gases. So from the pre-scrubber, the carbon dioxide the flue gases go into the absorber column, where we have it comes into contact with the amine solvent. This amine solvent having a greater affinity toward the carbon dioxide, which absorbs the carbon dioxide from the flue gases, and the flue gases from free from carbon dioxide can be obtained from the top of the absorber column, and we get the rich amine solvent from the bottom of the columns, and we are going to regenerate this rich amine in the desorber column. You can say desorber column, regenerator, or stripping. There are so many terminologies used across industry. Basically, it is again an absorption column having packed back columns here, which is increasing the the surface area between the solvent and the gases. In the desorber column, what happened? We provide the heat. With the impact of heat, what happened? This amine solvent emit the carbon dioxide, the pure carbon dioxide, and it will again regenerate itself into a lean amine, which is nothing, just CO2 lean amine. So what happened that this CO2, the captured CO2, we are going to compress, and we have to find the ways how it can be utilized for further application, whether we have to convert it into methanol, ethanol, or maybe we can go for EOR, this is enhanced oil recovery, or we can look for permanent storage. So when we talk about this technology, there are key equipments which are booster fans, the scrubber columns, the absorber columns, the regenerator, trim coolers, heat exchangers, solvent tanks, CO2 compression storage, and reclaimers. So what are the technical challenges of capturing the carbon dioxide from the flue gases? So let me see the 4 major challenges one by one. The first one is the SOx and NOx interference. In fact, when you are going to talk about the amine solvent, then the biggest problem of amine solvent is that it interacts with the SOx. SOx basically is SO2 from the flue gases. It forms heat stable salts. So this heat stable salt reduces the capture capacity, and also it required frequent, you can say, refilling of solvent into this circulation loop. There are also amine losses and corrosion problems. With this technology, we have faced, there are issues of amine losses. The amine solvent will also get, you can say, in the fine droplets, it will also go out with the flue gases into the atmosphere. So it again poses a big problem that some amine will also contaminate the environment. So we have to see how we can reduce these amine losses. And in fact, this amine solvent is very corrosive in nature. It is very alkaline. And when it comes into CO2, then again it forms some kind of, you can say, acidic solutions. So we have to see how the corrosion problems can be dealt. Because if we are going to deploy this solution at long term, say 15, 20 years, then we have to find ways and we have to find correct solvent which will not having a much severe corrosion impact on the columns. There is also a great impact of oxygen. This oxygen accelerates the solvent degradation through oxidative pathways. In fact, we see that most of the amine solvent, you can say the conventional amine solvents are not good to deal with oxygen content having more than 1%. But when you talk about the specialized amine solvent, then people are claiming that their amine solvents are able to handle the oxygen up to 5 to 7%. But still, we need to further find the ways how this oxygen impact can be dealt in the amine solvents. The energy intensity. The energy intensity is the most biggest problem in this particular process. It requires a huge amount of energy. Why a huge amount of energy is required? This energy is required to regenerate the solvent. In fact, you know that in the flue gases, the carbon dioxide is having a concentration from 10 to 15%. It is a very low in concentration in the flue gases. So flue gases having low concentration of CO2 required more energy, in fact, for the regeneration. Because the low concentration of flue gases will require more, you can say, viable solution which can easily remove this low concentration of flue gases from the low concentration of carbon dioxide from the flue gases. Now talk about the post-combustion carbon capture. We have talked about the post-combustion carbon capture. Now we see how it will contribute in the CCUS value chain. We have to capture the carbon dioxide using the post-combustion technologies in which you are, as I told you, that you have to capture the carbon dioxide from the flue gases of large point sources. Then you need to compress it. Compression is also pose a big challenge. I was also doing some study how much will the cost of compression in this particular cycle. Then it will be a, you can say, a huge figure coming in before us. We found that the compression of carbon dioxide also poses a big problem because it contributes a huge cost. In fact, 30 to you can say 20 to 30% of cost in this particular cycle is contributed to compression itself only. Further, we have to find the ways. We have to find the ways where we can utilize this carbon dioxide. There are ways people are working on. In fact, maybe IIT Guwahati is also working in the ways where you can utilize the carbon dioxide. In the maybe there are at present people are working in India. Like you can convert it into some fuels like methanol, and you can utilize it into EOR, the enhanced oil recovery, and you can talk about the permanent storage of the carbon dioxide. But still the research is going on, and people are working in this particular sector. And when we are talking about the reality, when you will see the full-fledged carbon capture adoption by the industries, then we have to see the complete chain. If we are having a viable and cost-effective solution for utilization, then definitely industries will adopt it. Because merely capturing the carbon dioxide from the point sources will not solve the problem. It's a huge cost to the industry that they have to deploy a separate setup to capture the carbon dioxide. There, it will reduce the efficiency of the industries itself, and also what we can do with this captured carbon dioxide. So let me see the overall challenges with the capture of carbon dioxide by the amine solvent. We see that it is an energy intensive process. It required a high solvent regeneration energy. It ranges from 3.5 to 4.5 gigajoules per ton of CO2 captured. People are working in this area. In fact, some companies are saying that they have reduced this regeneration energy below 3.5. But practically, when we have assessed those technology, we found that those claims are not that much, you can say, promising, because overall the energy you can say contribution lying in this range only. As I told, the biggest problem of adopting the carbon capture is the end product, where we are going to utilize the carbon dioxide. In fact, I personally feel that this is the biggest challenge where people have to work, because in India, if we look at how we are going to reduce the carbon impact, so we see that the government is working in the hydrogen, government is also working in the coal gasification, government is also coming with a policy for carbon capture also. So when you talk about the coal gasification or carbon capture, then you need to find where are we going to utilize those captured carbon dioxide. So it's a big problem right now. In fact, people are working across the world which provide us some viable and cost-effective solutions. So energy, when you are going to adopt 90% of carbon capture in the industry, then you have to face a huge penalty. In the sense of energy. In fact, a study says that if 90% of carbon capture is going to deploy it, suppose in a particular captive power plant or in full power plant, then it will reduce the output by 3 to 40%. So it's a huge penalty, because the output will be reduced and it will impact the prices of their power generation or the prices of their product. The solvent degradation is also a big challenge, which I have already covered in the technical challenges. Also, the high steam requirement for this technology poses a big challenge. In fact, this energy consumption and high steam consumption is nearly interlinked. And the big challenge, what we are facing also, the emission of solvent into the atmosphere. In fact, in many of the cases, the emission are quite high, from 0.35 kg to, in fact, in some cases, I have seen that 0.75 kg of CO2, sorry, this amine solvent is emitted into the atmosphere. And this amine solvent, it again poses a big challenge. It will also contribute to the global warming itself. So we have to reduce the carbon, amine solvent emission from the carbon capture plants. So these are the biggest challenges. Any questions so far? Anyone?
We can take it at the end.
Okay, fine. So let's talk about the global carbon capture initiatives. Okay, how world is working in this area. So we see that there are at present 45 commercial facilities available. I'm talking about the commercial facilities here only, not about the and research facilities. There are many more facilities of pilot and research level. But when we talk about the commercial scale, then the post-combustion carbon capture facility particularly we are facing the global challenges, global warming challenges. In fact, a recent study by RBI itself also indicate that there will be a huge loss to assets in the coastal regions, not even in the coastal regions, in the you can say inside the country also, because of this global warming. In order to stop the impact of global warming, we have to find the ways how we can reduce the carbon dioxide into the atmosphere. Because wherever you are going to talk about in the industry, then they always talk about this carbon capture is a huge cost requirement will be there, and the product cost will go up. But they don't visualize in the future they will have to face the bigger challenges of global warming impact. Their assets will be damaged. In fact, in many coastal regions, we have seen so many calamities occurred in the recent past. In fact, the weather conditions are changing so frequently, which also causes a big challenge to the industries to operate. So we have to look in that sense also, because we are losing those assets also. If we not going to take steps right now, we have to pay all those. In fact, if we have to pay much higher than what we are talking about your investment in the capture. So there are so many government policy supports from the USA, Europe, Japan, which are you can say promisingly moving in this direction. Because of the time limitation, I am not going to cover each of these countries' major initiatives. I am just telling that there are some incentives. In fact, some fundings are also being provided. Viability fundings are also being provided in these countries, which support, in fact, this which help the adoption of carbon capture in this particular industries. So let's talk about the Indian scenario. In India, people are working in this area since long. In fact, I am not wrong that IIT Guwahati has also done some project with NTPC in the past on capturing the carbon dioxide. But still, we don't have any promising technology, and we need to further just look into our R&D, how we shall develop an indigenous technology for carbon capture. Simultaneously, we have to see how this carbon dioxide can be utilized. So I am just capturing the scenarios from the 2019 onwards, because from the 2019 onwards, we see that Indian government, in fact, the industries are looking this is as a serious step to reduce their carbon emission, and in order to meet the global standards and the global requirement itself. In fact, our businesses are also going to be hampered because of if we are continuing to emit the carbon dioxide from the industries. Many of you have heard about the CBAM, which was a carbon border adjustment mechanism, which is going to be adopted by the Europe in the 2026. Then they will ask you how much carbon dioxide is being embedded in your product, and they will in fact penalize you if your product is having a carbon dioxide emission, a huge carbon dioxide emission, then it will penalize you, and your product will be cost more in that particular market. So in fact, Indian steel industries will be impacted because of this initiatives by the Europe. So in fact, there are so many conferences are being carried out which say that we have to buy the green products. We have to find the ways how we can force the industries to reduce their carbon emissions. So this is the way they found they have to focus on the green products. And I will also talk about another technique, which is the carbon credit. But personally, I feel that carbon credit technology is not much effective because it was quite long in the market. But this carbon credit, you can say, mechanism is not helped to reduce the carbon emissions from the environment. In fact, only it is shifting the burden. It is shifting the burden of the emitting industry to the less emitting industry, and you are only buying the credits, and you are just keeping yourself away from the technology advancement or from the methods of adopting which can help you to reduce your carbon dioxide emissions. So let's talk about the government of India initiatives. So you see that from the 2019 onward, there are so many projects being funded by the DST. In fact, some industries are also funding. In fact, BHEL has been recently awarded a project on conversion of carbon dioxide to DME. We are working to develop a technology, indigenous technology, which can convert the carbon dioxide to DME. Why DME we are talking about? DME is nothing, it's a dimethyl ether. We found that dimethyl ether can be a good source for replacement of LPG, or you can say we can just use some percentage of DME into the present LPG, which will help us to reduce our oil import, or you can say natural gas import, or which will help to reduce your import bills. So we are working in that direction also. In fact, in 2021, India has also committed that we will become net zero by 2070, and we will reduce our carbon emissions by 50% by 2050. In fact, 2022, 3 Center of Excellence has been formed in the country, which is at IIT Mumbai, JNCR Bengaluru, and NIRI Nagpur. In November 2022, NITI Aayog has published a detailed report on CCUS policy framework and how it can be deployed in India. In fact, I was also part of this report, which talks about what are the ways we can deploy in India for the carbon dioxide capturing and how the funding supports can be obtained. In June 2023, a national level carbon traded market has been notified. In fact, recently, for some sectors, this carbon trading scheme has been launched. This carbon trading scheme is talk about that you have to reduce your carbon emissions year by year, and if you are not able to meet the reduction in carbon dioxide, then you have to buy a carbon credit. So, for recently, this particular scheme has been launched for some industry like 𝗚𝗏, alumina, and I guess some cement industries are also covered in that particular scheme. So it is showing that government of India is quite serious in this sense that they are forcing, in fact not forcing, they are just promoting the industries to adopt the ways where they can reduce their carbon dioxide emissions. Now look at that from 2024, BIS is also working on the national level standard on CCUS. In fact, I was also a member in the BIS team where we are working on how the international standards, or we can develop our own standards for CCUS. Because CCUS is a new technology, there is no standards available in the India. In fact, there are some ISO standards available internationally. Then we have to find whether we can adopt those standards as it is, or there may be some relaxations to be adopted, so that we shall not hamper our indigenous and developed technologies. We shall not hamper our R&D initiatives, because those standards which has been designed internationally are taken care of the mature technologies. So those mature technologies, if we are going to adopt as it is in India, then it will pose a great threat to indigenization of our technologies, or it will also give a setback to R&Ds, because in R&D, in pilot setup, at present various organizations are working, so they need some relaxations when we are going to draft such kind of standards in the country. So in 2024, in fact, ongoing, there are so many conferences has been organized by so many organizations like NITI Aayog, BEE, Ministry of Power, and so on. In fact, IIT Guwahati has also joined in this initiative. They have now also making people sensitive on this matter of carbon dioxide. And I am also very grateful to IIT Guwahati that they allowed me to share my views in this direction. The biggest initiative of government of India we are expecting in the upcoming days. We are expecting a CCUS mission. This CCUS mission will help industries, in fact the academias also, to work in this direction. It is expected that 39,000 crores of funding will be supported by government of India through the R&D initiatives or for the deployment of commercial plants also. So we are hopeful that in this financial itself, this mission will be rolled out, and it will also, as I told you, that it is planned that maybe around 38,000 to 39,000 crores of funding support will be provided by the government of India for the adoption of carbon capture, utilization and storage techniques in India. Now let's talk about the existing carbon capture facilities in India. When I talk about the carbon capture facilities here, I'm talking about the capturing of carbon dioxide from the flue gases. I'm not talking about the capturing of carbon dioxide from the urea process or from the gasification process or from any other process. I'm talking about the post-combustion carbon capture technologies which has been adopted in India. Because as I told in my earlier slides, the biggest problem of India is that most of the industrial assets are new. So we cannot replace our industrial assets. We have to find the ways where our technology can be adopted, which will reduce the carbon dioxide from the flue gases. So post-combustion carbon capture is the viable solution people are looking for. So these are the four you can say facilities operating at present in India. The first one is the 2,3-chlorine alkali chemicals, which is capturing something 165 tons per day of carbon dioxide, and they are converting this carbon dioxide into soda ash. This soda ash they are consuming in their internal processes itself. In Vishnu Chemicals, they are also having 174 tons per day of carbon dioxide capturing facility, where they are converting this carbon dioxide into carbonic acids. In fact, recently Tata Steel and NTPC Vindhyachal has come up with some facilities that Tata Steel has set up a 5 TPD plant and NTPC Vindhyachal has set up a 20 TPD plant. So these plants basically are pilot scale plant. So they are finding ways whether they have to go for full scale or not. In NTPC Vindhyachal, they are converting the carbon dioxide into methanol. Recently, they were able to successfully convert it into methanol. So let's talk about the financial numbers. The financial numbers I have taken is from the public sources here. We are also working on the financial numbers, how the large scale deployment of carbon dioxide will cost to the industry. But I am not able to disclose it here because I found it is at a very premature stage, and further elaboration or further working on need to be carried out. So let's see what are the numbers here. When we talk about the carbon capture cost for thermal power plant, I am taking an example of thermal power plant here. But when we talk about the steel industry, the cement industry, or the refineries, then this cost of capture is something near to this only. It is not, you can say, big difference from this, but it is near to this only. Only huge changes, not a huge changes you can expect in the cost. So from the Niti Aayog report, they say around 800 crores of capex we will needed to capture to set up a plant of 1 million metric ton per annum. But I personally feel that this figure is quite low, because right now I am also working in this area and I found it may cost more. The cost of this setup cost will be much higher from 800 crores. But still we are working, we are finding ways how this cost can be reduced, and we are hopeful that it will, you can say, not cross 1,500 of crores, but at present we are finding it is at a higher level. When we talk about the OPEX, then the OPEX contributes around 2,100 to 2,500 into the cost of capturing. So the levelized cost of capture for thermal power plants is coming out to be 2,800 to 3,500. So this levelized cost of capture is taking care of capex and opex also. So you see that the per ton of cost of capture will contribute a huge cost to a particular industry. Because if we suppose if we take a 500 megawatt of power plant, then it is nearly emitting around 3 to 4 million metric ton of carbon dioxide into the atmosphere. Million metric ton of carbon dioxide into the atmosphere. When we talk about the capturing, then definitely it will cost huge to the particular industry. So industries are looking at ways where they can sell this carbon dioxide. So there is no buyers available in the market who can buy carbon dioxide approx some. If you talk about the bottling plant, there is a very minute consumption of bottling plants, this CO2 beverages. But when you are going to capture the huge amount of carbon dioxide, then you have to find how this carbon dioxide can help us to generate some revenues. So in this direction, people are looking that why not we convert this carbon dioxide into some chemicals or some fuels. So we, in fact, in BHR also, we are working like converting the carbon dioxide into methanol and dimethyl ether. So again, this methanol and dimethyl ether is again a fuel which after burning will again emit the carbon dioxide. But right now, India is working in two directions. They are not only looking to reduce their carbon dioxide emissions, because if you see that our per capita emission is quite low, we are also looking to reduce our import bills. If we are able to reduce our oil consumption, because most of our crude oil is imported, if we are able to reduce the impact of imports, then definitely we will reduce the export bills. Also, we will reduce the emission from those sources also, if we are able to convert the captured carbon dioxide into some fuel. So that is the logic behind India is also promoting that, converting carbon dioxide into another fuel like methanol, DME, ethanol, and so on. But the biggest challenge with this particular thing is the hydrogen, because when you are talking about converting carbon dioxide into some fuels, then you need a hydrogen. And from where this hydrogen can come? This hydrogen can come from the blue sources or from the green sources. But if you are talking about the blue sources, then again, this blue sources is having some emissions of carbon dioxide that it is not feasible, and we cannot produce the green chemicals. So we found that green hydrogen can be adopted. But the problem of green hydrogen is the cost. At present, the cost of green hydrogen is quite high. In fact, recently tenders floated by Government of India in some schemes, we found that the cost of green hydrogen is something around 350 rupees to 400 rupees per kg. So it's a huge cost. In fact, with this cost, if we are going to, suppose we have done some studies and we found that if with this cost, if you are going to convert it into methanol, say methanol, then the methanol will cost around 4 to 5 times from the conventional sources. So the conventional sources, if you are getting methanol something suppose at 30 rupees per kg, then with this green hydrogen cost, you may land up a cost of methanol generation from you can say 120 to 150, in some cases up to 100 rupees per kg. So the cost of methanol will be high. So we see how this cost of methanol generation from the carbon dioxide can be minimized, so it can be adopted by the industries. In fact, government is looking to provide some incentives when you are going to use the green methanol for the there are some policies in India also which says if you are using shipping in shipping industry, then green methanol can be adopted as a fuel. In fact, in world itself, there are so many shipping industries, they are asking that if you provide them green methanol, then they are ready to buy at a higher cost. So because they are getting some support from their particular government, some viability fundings are also there. But still, it's a long way we have to go. We have to find ways to reduce this cost by our R&D and by our, you can say, innovative minds across the industry. We have to find how the indigenous technology, cost-effective, viable, and scalable technology can be developed. So if you look at the business potential, I really not say business potential, I have to say how much investment will be needed when we talk about the capturing the carbon dioxide from our industries in India. So we see that if we are going to capture something around 20 to 30 million metric ton per annum by 2030, then it will cost around 30 to 50,000 of crores. So it's a huge cost to the industry. Then in fact, this 30 to 50,000 crores may go up, because many of the plants which are at a very nascent stage are working on this. They found that the cost of capturing is a little bit higher, because many of the raw material, many of the cost of construction has shoot up. So we may expect this cost will also go up. But if you look at the long picture, if we have to be a carbon neutral, then we see that there are some industries saying that we have to at least capture 750 million metric tons of carbon dioxide by 2050. So this capturing of carbon dioxide will require a huge investment, tune around 5 to 6 lakhs of crores. So I am just talking about these figures in the sense of carbon capture only. But when you are going to compress it, you are going to utilize it, this cost will also go up. So if you look at the particular market of carbon capture by 2050, then I can say that it will ranges from 15 lakh, something around 15 lakh crores. When you talk about the whole value chain, from capturing to compression to utilization or storage. So I hope this is the things which I am able to cover what is going on in India, what are the technology parameters we are looking for the technology deployment and so on. So I thank you very much, and I hope that I have completed my slides within the time frame. So any questions you may please ask.
Hello. Hello, sir.
Yes, please.
Good afternoon, sir. My first question is, what are the most common bottlenecks you face when you're scaling up carbon capture units from the pilot to full-scale operations?
When you talk about the scale up of carbon dioxide from the, you can say from the present pilot scale to full scale, the biggest problem is the cost and not in fact the cost, how we are going to regenerate the solvents. So this regeneration of solvent will require a huge amount of energy, which can be supplied through from the electrical sources or from the steam. So when you are going to utilize the steam or the electrical sources, then again your output of the plant will reduce. So it will pose a big challenge. Like you need, you can say additional boilers or additional setup to provide this much of energy. So it's a big problem right now we are facing when we talk about the scale up, because we have to see the penalties also. And from the technical side also, there are some issues because most of the pilot plants are run for very, you can say, short period. In fact, in the commercial scales, whatever we are having commercial references across the world, they are quite new. When we talk about the capturing of carbon dioxide from the flue gases, so there may be challenges like the amine emission into the atmosphere, the corrosion challenges are also there. So we have to look in that direction also.
Yeah. And second question is, and what is your take on the economic viability of direct air capture versus point sources captures in industrial settings?
Right now, you see that the direct air capture is also at a very nascent stage. People are just doing R&D in this direct air capture. And when I see the cost of direct air capture, it is very high. So it will be difficult to adopt the direct air capture at present. But maybe in future, we see that direct air capture plants will rise up. But the problem with the direct air capture is that it will only capture carbon dioxide near to the plant where it is being set up. But when we talk about the capturing of carbon dioxide from the point sources, from the industrial setups, then you have to capture the carbon dioxide from the industry itself. So it will reduce the impact of carbon dioxide in totality into the atmosphere. So both of the options people are looking on. In urban sectors, we can say direct air captures will help, but when you look at the industrial setups, then still we found that large scale capture from the point sources is quite feasible at present.
Thank you, sir.
Hello, sir. This is Madhvi. I really like this topic, and I'm a PhD scholar, so my area is also around this. Like I am working on carbon emission reduction through machine learning. Like I'm going to use some data and predict, like in coming future, maybe in 2050 and 2070, how it is going to look like. So, as you have mentioned, the source of carbon emissions, you have also mentioned about the transportation sector. So my area is also related to that only. So I just wanted to know from you, like if you have some idea about it, like what are the data sources from India, from where we can get that what amount of carbon is emitted from a particular sector in India, and how reliable they are, how accurate they are.
You are raising a very good question. In fact, in India, we don't have any mechanism which say industry to report their carbon dioxide emissions. Okay, so what happened that I was also part of a report which was published by Niti Aayog. So this was the biggest challenge with us. So the possible way we found that we have to see some plants, some you can say some sample plants, and we see how much carbon dioxide they are emitting. Okay, and on that basis we have extrapolated how much carbon dioxide is being emitted from across the nations. Okay, so this is the method we have adopted. But if you look at ready reference where you can get the latest update how much data, how much carbon dioxide we are emitting. So we see that India is disclosing some of their emissions to the IEA. It is an International Energy Agency. If you go through the data of IEA, which is publicly available, so you can find that most of the data they have published there, how much industries are emitting. Actually, this is a, you can say, data in totality. Okay, it is not sector, it is not industry wise, like particular industry they have not notified. Suppose so and so plant, how much they are emitting. They have reported a data in totality, that how much power sector is emitting, how much steel sector is emitting, how much other sectors are emitting. So you can get some ready reference from their data.
Yeah. I'm aware of IEA, International Energy Agency, and I'm also like very like found in several papers that they have cited this reference. But still, the question is that are their data are exact in the Indian point of view, or they are using cumulative data, or
No, they
like
are
how
they are in
reliable?
fact they are in fact asking from the Indian government, Indian sources also, they have to report how much they are emitting. Okay, so their data is you cannot deny they are not reliable. It is reliable itself. In fact, when you look at the Niti Aayog report, which was published in 2022. Okay, so you will find that that the data of emission they have published, it is near to that IEA reported data at that time. Okay, so you can also refer some public, you can say, disclosure by government also. Time to time, whenever this conference of party is going to happen, then sometime government also discloses this much sector is also. But this is not you cannot get this data on a single dashboard. You have to collect it from the various sources.
Yes.
If you want, I can help one thing. I can give you, like, in India, most of the power plants are being set up by BHL itself. In fact, we are having around 72% of installations of power plants in India. Okay, so we have the data how much are different capacity of power plants are emitting CO2. So if you want that data, then I can help you to provide. Suppose so and so capacity, suppose 500 megawatt, 800 megawatt, or some lesser capacity, how much carbon dioxide or how much flue gases they are generating. But still, that depends on the age of the plant. Suppose if the plant is going to be aged more, then definitely more flue gases will be generated there with respect to the new plant.
Okay, sir. I just wanted to have your contact. Like in future, if I need it, I'll wanted to contact you.
Sure. I will share my contact with the SPT. In fact, they have my contact with me, so you can ask them to share.
Okay, sir. Thank you.
Moderator. Pradeep.
Yes, sir.
Anyone there?
Hello.
Yeah, yes, sir.
I
Yes, sir.
have a
You are
question. I
audible.
will ask that.
Yeah. Good afternoon. This is B. Mandal from Chemical Engineering Faculty at IIT Guwahati. Yeah. So actually, my query is now BHEL is involved in any R&D with any academic institute at present for carbon capture?
Yes, sir. Actually, we are working with the IIT, Hyderabad. Okay, this is,
IIT.
yeah. In fact, we are working on two projects with IIT. The first one is talking about the phase change solvent, development of phase change solvent. And the other project is about the conversion of carbon dioxide into DME. So these two projects we are working with the IIT. In fact, sir, what I feel key in India, this carbon mission is going to be rolled out in the upcoming days. So there will be a huge funding opportunities from the government in India itself. So we have to find not even working on the basic R&D. The biggest challenge is the industries are facing when you talk about the adoption of technology from our indigenous sources. The biggest challenges is they don't have proper references. Further, they lack in engineering services. Okay. So what I feel is that whenever new projects will be taken care of, then it will look in that perspective also. You have to carry out the basic R&D, then you have to find and provide a solution to industry that detail engineering can also be taken care of. Okay, because
Yes.
for detail engineering, we again have to go to some foreign parties, then they will charge huge money. And again, the cost of you can say the indigenization of technology will be compromised. So in that direction, we have to look forward.
Yes. So initially, for a long time back, we worked with BHEL, that is a simulation project in 2009 on carbon capture. So after that, NTPC, we worked with NTPC on pilot plant data generation on carbon capture with solvent. So we did a pilot scale study at IIT Guwahati. We also work on membrane based carbon capture with, now we are working with GAIL for their natural gas carbon capture. So IIT Guwahati has a very strong team on carbon capture and utilization, and Dr. Sumit is also working on utilization, enhanced oil recovery and all. So in future we may be associated with BHEL for carbon capture and utilization related work.
Sure, sir. Sure, sir. In fact, I will approach personally with your people, with your faculty members, whenever if we feel in another kind of project we have to take up, because already we are working on two projects, but still I feel that we have to look on the membrane separations or the adsorbents also for the future deployment, because amine solvents are having their basic problems, which I have covered in my slides itself. Amine emissions are always there. In fact, the corrosion problems will always be there, and for future deployment, we have to find the other ways also.
Yes.
Professor Vishnu.
Yes.
I have a plan to connect industry like Rahul ji and all other experts from Coal India as well for a kind of consortia thing that we can build in IIT Guwahati for whole value chain for CCUS.
Yes.
So
I will. Go ahead.
Yeah. So that thing we can discuss separately, because for that we have to onboard BHEL, CIEL, top management team also, and then we will discuss it separately.
Yeah, sure.
Yeah, thank you so much.
I had a question.
Yes, please.
I had a question. So you talked about the cryogenic technique for separations, right?
Right.
So how the gas hydrate kind of which will be added technology along with cryogenic will help separating the CO2. Will it add some advantage, or it will be energy intensive, or what is your comment on that?
You are talking about from which gases?
Flue gas.
Sir, in the flue gases, we found that the cryogenic setups are quite difficult to operate in the sense of because the carbon dioxide percentage, mole percentage in the flue gases is quite low. It is just roughly 10 to 12%. In fact, in some sources, it may go below 10% also. So when you are going to adopt the cryogenic technique, then it will require a huge amount of energy. So in fact, it is not commercially viable solution which we feel is available at present for flue gases. But it can be adopted from other sources, like in fact from the which are having high carbon dioxide content, like syn gases. That can be worked out. But from the flue gases perspective, I found that it will be relatively difficult for cryogenics. Whatever technology available at present. I'm not talking about the future or some initiatives we are working on. I'm talking about whatever the technology is available at present.
Okay. Rajdeep.
Yes, sir.
Hello, sir.
Hello, sir.
Sir, how do you validate your simulation models with actual process plant data?
We have, in fact, our R&D team is having several softwares. They are using some. In fact, let me tell you one thing. Like BHL is also having a pilot plant of carbon capture that is 1.4 tons per day. Okay, so this pilot plant is basically a part of our setup in Hyderabad. This particular setup is about converting coal into methanol. In this, we have a carbon capture plant. So we are capturing this data from the pilot plants also, and continuously our team are working on that. We have Aspen softwares available with us, and some other softwares are also available with our team. So it is available with BHL corporate R&D team.
Are there any more questions?
I have one question.
Okay.
Sir, what is the future scope in carbon utilization and storage aspects? I know it is still in R&D, but what is the future scope in that sense about the carbon storage particularly?
Let me assure you one thing, like if you come with a solution which say ki you can utilize your carbon dioxide and generate some revenue, then I can find the industries which can adopt your technology. Okay, the problem is with the industry, they are ready to adopt the carbon capture. It is not a difficult thing, but the problem ki how they can generate the further revenue, because in India, cost of product is also very important. If the cost of electricity goes up, there will be a political and economical crisis. If the cost of some general commodities, suppose like steel, will go up, it will also pose a problem. Because singularly, if you talk about the carbon capture, then cost will go up. But if you give some solutions which say, yeah, you can use this carbon dioxide and convert it into some product which will generate some revenue for you, then definitely we can find ways to adopt the technology. Now coming to your second question, how you look at the storage. Okay, so you see that storage part is very nascent for India. Okay, we are a developing nation, and when you talk about the storage, then a cost will be incurred. Okay, now you have to incur a cost of capture. Now you have to incur the cost of transportation plus storage. And further, there are mapping of the sites that still need to be carried out, which are suitable for storage, which is still pending in India. Okay, so storage technologies are also not available in India, if I say correctly. So you see that storage is at present India will not opt for. Okay, because it required a further cost from the carbon capture itself. You are incurring cost, and you are on storage. You have to incur the cost. So India is more looking toward the utilization of carbon dioxide. So this is the future at present I am looking for. In fact, if you see the government is not only when they talk about the capturing the carbon dioxide and utilizing it, they are not only trying to reduce the impact of carbon dioxide from the atmosphere. They are playing, they are in fact targeting two things. They are targeting reducing their import bills of oils also, dependency of oil in India. In fact, coal gasification mission has been announced, which around 8,000 crores of incentives. In fact, BHEL has also got the government funding of 1,350 crores to set up a plant on coal gasification. So they are looking ki you utilize our indigenous coal and you just help us to reduce the import bills. Okay. So in this particular project, we are going to produce the ammonium nitrate, and in fact some other projects are also CIL and GAIL and DPC are also working. They are going to convert it into natural gas and some other. So all these projects not only targeting the reduction of carbon dioxide, they are also targeting how the import bills can be reduced. So I guess I answered your question.
Yes, sir. Thank you.
Okay. Thank you very much, sir, for an insightful talk and this engaging Q&A session on CCUS. Your talk has given us a deeper understanding on the industrial aspect of CCUS and its vital role in the Indian aspect. On behalf of the IIT Guwahati SPE student chapter, I extend our heartfelt gratitude to you for taking the time to be with us and sharing your expertise. Our sincere thanks also go to our faculty advisor, Professor 𝗍𝗵𝗂𝗧 sir, for his continued guidance, and to the organizing team for their smooth coordination, and to all the participants for joining and making this session interactive. We hope to continue learning from such valuable collaborations between academia and industry. Thank you all once again for being part of today's workshop. Have a great day ahead. Thank you.
I am also thankful to SPE team and to faculties of IIT Guwahati that they just started this initiative to spread awareness about the carbon capture utilization. And I am hopeful that IIT Guwahati will also come up with some viable and cost-effective solution in the near future. As I come to know that faculty members in IIT Guwahati are also working in this direction. Many PhD scholars are also working in this direction. And I am hopeful, and I will also see that some solutions in the near future we will get from the IIT Guwahati itself. And thank you very much. Thank you very much to the team of SPE and to the faculty members and to all the participants here. Thank you very much.
Thank you, sir.
Akash, please.
Yes, sir.
Hello. Kindly conclude. Conclude it, no?
Yes, sir. So thank you to everyone for attending this session. I would like to conclude this meeting, and thank you for your questions that were sent during the Q&A session. Okay.